here's what I'm after. Biomass production, we think about growing stuff out there. What I'm growing is not only my annual crop. Our annual grain crop typically, sometimes starts in the spring, depends what it is, corn, soybeans, they really start actively growing in May. They got some peak growth, you got the most water use going on, most biomass production going on, and then we taper off in the fall, and when we actually look across the year, we're actually only harvesting sunlight, carbon dioxide, and water about 5 months a year out there. Now, to sell a cash crop, that's fine, that's my production. But when you think about the soil system, when you think about what Mother Nature had, when you look at native systems, we didn't have something growing there only 5 months a year. There was something growing there close to year round, depending upon the winter, depending upon the species, whatever. And that's what we're after when we start looking at cover crops. After harvest, we've got an opportunity here where we've got some losses. We might have some extra nutrients out there that can be leached away. We got some extra water, rainfall that's coming in, our soil's already saturated, that's lost because we can't use that water, can't store it. Now, water can be stored in the soil. Sunlight and carbon dioxide can't be stored. When I look at, again, producing a crop only 5 months a year, I got 7 months a year worth of sunlight and carbon dioxide I could be doing something with. NRCS has got some cover crop assistance, some equip dollars in some areas. Some NRDs have some cost share dollars available as well. And they are promoting, primarily, their top reason is going to be erosion control, conserving our natural resource. They have that on their list here. I put it on the top of the list as well. Grow something out there. We've got producers in the Sandhills who've done that for years. They chop silage for their feedlot, and they'll go out there and plant a cover crop out there. That does double duty for them because not only do they protect the soil, they can have on the other end of the scale some grazing. They get a fall pasture then out there as well. But again, there's a wide variety of reasons out there, and whatever your reason is, then will guide a little bit of what you're going to select for a cover crop. Nutrient capture, nutrient cycling. Two different things there, but what we're looking at then is using that cover crop to help us as a nutrient sink. And it could be, for instance, there's some areas of the state this year that got hailed. Had full fertilizer on for irrigated corn. Hailed out, corn's been killed. What's growing there to use the nitrogen that we applied? Maybe some weeds. Well, why not control it by growing some cover crop there and take that nitrogen that's in the soil, put it in a biological form in the residue that will break down later. Jim's going to talk a little bit about some research they've been doing on that, but that's captured such that that nitrogen that's in the soil profile won't be lost to leaching. So that's what we're talking about on capture. Now, cycling is we're going to get that into a biological form such that we can cycle it when that residue breaks down. And we see more examples of that when people are out there applying manure, for instance. After they've applied manure, plant a cover crop there to grow some of the nutrients right up into that, and you got to start cycling into the system then. Improving soil health is what we're in after in the longer term. That's why I say for no-till is sort of my next step. We've been no-tilling for a few years to build up the soil. We can build it up more by growing something more times a year. Feed those soil microbes, get the system working for us. The soil health thing, you won't see year one of a cover crop. Yeah, you might see some advantages, but to really get soil health going, it's going to take a couple of years, and it's going to take a more diverse mix in the cover crop to get more diversity to help build that soil. Sam will talk a little bit about diversity as well. That increasing the biological diversity comes along with that, and again, they'll talk more about that. Water management, I already talked a little bit about it. If you got plenty of water, use the cover crop to grow the water out. And too often we've heard it, that field's too wet to plant, go till it to dry it out. I'd rather grow the water out, grow some roots there, grow some biomass, and don't do tillage to destroy soil structure.
We planted, and I can show you a picture, an aerial picture. On his farm, we planted 5 different cover crop blends. And we replicated it, and so we did it in a scientific manner. So we had 4 reps of each of these. The blends you'll see on the top, the names maybe don't mean a whole lot to you, but if you look down here, you can see their percentage by seed number of grass and brassicas and legumes. And if you wanted more detail, I could go back to my notes and tell you specifics about what these are. I don't remember them all. But that's what we got. And we planted these August 6th in a dryland wheat stubble. And on the 10th or 11th of November or October, we took above ground biomass samples. So we laid out a 3 by 3 foot square, and I took a gas powered edge clipper. We cut everything everything off the top, and we stuffed it in a lawn and leaf bag, and I ran it to Ward Labs in Kearney, and they analyzed it for carbon and nitrogen. So with these 5 mixes, it's interesting that we literally produced about a ton of carbon per acre. We got a lot of carbon to the system with it. And then this is the nitrogen numbers. The nitrogen ranged from 71 pounds up to 118 pounds. And so net, you'd say, well, maybe we take off to 19 pounds, and that's what we produced. You might also figure that some nitrogen might have mineralized during the season, and that was going on too. So we're not really for sure, but we know that we netted more nitrogen than we would have without it. I want to focus in on the carbon to nitrogen ratio, because I think this is really key. If you're interested in producing nitrogen and having that feed your next crop, you need to understand what carbon to nitrogen ratios mean. And basically it's the ratio of the amount of carbon to nitrogen. Now, the nitrogen is key, but the more carbon we have in relation to the nitrogen, the more it's going to slow the release of that nitrogen to our following crop. Because the carbon, in order to break carbon out, you know, it actually takes nitrogen to break some of that down. So the lower the carbon to nitrogen ratio, the more available and the more nitrogen we're going to have. And like I mentioned, the lower the number, the carbon and nitrogen, the more quickly it's going to be released, and the more we can credit for next year's crop. So if it's down there to like 11 to 1, we're going to release it very quickly, and we can credit, we feel, as much as 50% for the next crop. We never say we're going to credit 100% of what the lab analysis says for the next crop, because we really don't know how much of that is lost to the environment or released to the atmosphere. But we feel that we can credit up to 50%. So basically we can credit for the next crop the max that we allow for credit. As that ratio climbs, here's a 14 to 1, then we're looking at probably early summer. Now actually that AC green mix with the radish in was probably, I think that was about in that range. What was that?
You see,
16.6, so it's pretty close to that. And so we figure that that's going to be available for the next crop if it's a warm season crop. I probably should add the word crop there. If it's a warm season crop, which would be corn. Corn's a warm season grass. We figure that we're going to get some good out of that for next year's corn crop. It gets up to 20 to 1. We figure it'd release late summer. Probably safer not to credit it for next year, even if it's a corn crop. But we would hope that we're going to see that in the soil test in the fall, and then we can credit for the following crop. And 23 to 1, maybe some late summer, but probably more that's going to be available for the next crop. If you get up there to 70 to 1, here we're talking like wheat straw or corn stalks or something of that nature. Is going to have a carbon to nitrogen ratio of 71, and that's a long-term deal. I went out there on July 5th and I took some pictures because there's some neat observations. And here is my takeaway from them, is that both of these pictures represent plots that had absolutely no nitrogen put on for this corn crop. The only thing that was there was what was the residual and what the cover crop contributed. This is the check. There is no cover crop planted here. And here we have the AC green fix, the cover crop that produced the most nitrogen and had the best carbon to nitrogen ratio. This corn looks healthy. It's completely green. There's no signs of nitrogen deficiency. Here we've got nitrogen deficiency showing up on the lower leaves, and the plants are generally yellower. So this corn is actually healthier to begin with. There's a little more nitrogen in the soil for it to get started on than this. And the moral of that is that if we're going to use a cover crop, no matter how much nitrogen we produce with it, we're going to have to put some nitrogen on our corn to get it started. Research findings, nitrogen is scavenged from the rooting profile to contribute to the total above ground biomass. That's a given. It's going to use what's in the soil and put that into the above ground biomass. Where we had more residual nitrogen available, or if the previous crop was a legume, we've had more nitrogen in the above ground biomass. Later planted cover crops produce lower tonnage with lower carbon and nitrogen ratios. So we can plant the same cover crop a month later, and especially if we're looking at a mixture with grasses and legumes in it, we don't have the time to put the carbon into the grasses, and so thus the ratio of carbon and nitrogen is going to be less than if we planted it earlier and we pumped all that carbon into the grasses. And so that can be an advantage because that nitrogen will be released quicker in the following season. Above ground biomass nitrogen is not totally available in early season, the following corn crop, even with low carbon and nitrogen ratio, and that's the point I made with that picture.
So the first thing is that we're really looking at the benefits of increasing cover crop diversity, so the number of species that we include in a mixture. And when we go out and look at these cover crops planted here today, I think we've got about 8 or 9 different mixtures out there. And so you can see for yourself some of those benefits visually of cover crop mixtures. And what we did here is we've got cover crop productivity, or just biomass, on the y-axis, and then we've got the different cover crop treatment on the x-axis. And this WD is just the natural growing weed community out there, all the way up from a 2 to an 8 species mixture. So we're just adding 2 species at a time. To let you know that this is a spring planted cover crop mixture for this experiment. So we're planting in mid-March, first opportunity we have, broadcasting the cover crops, and then terminating them around mid-May. So this is productivity in mid-May. But these concepts apply whether it's a fall planted cover crop or a summer planted cover crop. The same concepts are true. So what we had this year, about the first week of May, was a pretty severe hailstorm up here at our research farm near Meade. And you can see that a lot of these species were pretty devastated by the hailstorm, especially the mustard species. And so the mustard species were a big component of this 2 species mixture, and also in the 4 species. And so you can see that our productivity was quite a bit lower in the 2 species mixture, and even a little bit lower in the 4 species, and it continued to get greater as you went towards the 6 and 8 species mixtures. So that's just one benefit of a cover crop mixture, is that it really provides insurance for the producer against either poor growth or extreme weather events. Another benefit is increased resource use efficiency. If you get these different species in a mixture, you're going to be utilizing nutrients and water at different soil profiles. So if you've got grasses with those fibrous root systems, you're going to utilize a lot of resources near the soil surface. If you get a mustard or a brassica, we'll look at some of those today, you get a nice deep taproot, so you're going to be utilizing some resources in the deeper soil profiles. You're also going to have different canopy structures, so you're going to really increase light interception for your overall plant community. And so ultimately we want to shoot for that greater productivity that we see out of these higher diversity mixtures. And now, like I mentioned, I'm primarily interested in the weed control benefits of these different cover crop mixtures. And many cover crop species are allelopathic to weed, individual weed species. Allelopathic meaning that the cover crop is going to have a negative feedback effect, or it's going to inhibit weed growth through chemical interactions in the soil. And what we found here is, like I mentioned, so on the y-axis we've got total weed biomass, and then those same cover crop treatments here. This is a no-cover treatment, so there's no cover crop planted and it was kept weed-free. Here we've got that weedy treatment where we just let the natural weed community grow for the first part of the season, and then from 2 up to 8 species of cover crops in that mixture. And as you saw in the picture, this yellow circle here is when we incorporated the cover crop with a disc. So in some cases we actually had more weed biomass than compared to a no cover control. So no weed control benefits from your cover crop in that situation. However, when you look at the undercutter, leave the residue on the soil surface and minimize soil inversion. Compared to the no cover control, all of these treatments resulted in lower weed biomass than the control. And what was most interesting was that the best weed control we saw was when we used that most diverse mixture.